This is a crude drawing of someone's basic, I guess, their nasal cavity, their mouth, and their throat, okay? The inside of their neck. So what we're looking at here is we've got a person's nose, okay? So the nose is right here. And the nose opens up, and this is your nasal cavity. Now, the job of the nasal cavity is just to inhale and exhale air. The only reason I've drawn it here is because the nasal cavity is actually linked to the back of the throat, also known as the pharynx. Okay, that is why when you drink something and somebody makes you laugh and you try to breathe at the same time, liquid can come back up out your nose. Okay? Now, what we're really interested in here is all of these parts are really key players in the process of ingesting food. Okay? So first things first, this whole area here in green is the mouth. Okay? And there's a lot going on when food is put into someone's mouth. First things first, two types of digestion occur. So when we look at what's happening here, we see that there's two instances of different types of digestion. Physical digestion involves breaking food down but not changing it at its atomic level. It's just making smaller pieces of the same type of food. And that is accomplished by the teeth. The role of the teeth in the mouth is to grind and break down or physically break down food. So while the teeth are actually grinding the food and breaking it down physically, you have small little glands here that are included in the mouth. And those glands are actually found underneath the tongue, okay? And those are called your salivary glands. And they inject saliva into your mouth. The inside of your mouth is always coated with a layer of mucus and saliva. And the mucus here is very thin, okay? You'll notice that if you put something in your mouth and chew it and then automatically spit it back out again, it's got kind of a slimy little layer to it, okay? That is very thick saliva, all right? Or a mucus secretion from the inside of your mouth. Now, the role of saliva is to start chemically breaking down the food. The role of saliva is to start digesting carbohydrates. And it accomplishes that by an enzyme in the actual mouth called amylase. So as the saliva is mixing with the food and your teeth are grinding the food, it's the role of the tongue, which is a huge muscle, okay? The tongue is actually one of the most powerful muscles in the body. And at any one time, it has, for its size, the most blood going through it, okay? It's got a tremendous amount of blood going through it at any one time. Very powerful muscle. And its job is to move food around the mouth as you're chewing it. It facilitates chewing, all right? And it helps form your food into more or less a ball. And that food, as you're eating it, so we're going to have this kind of ball here that your tongue is actually pushing towards the back of your mouth, okay? Your tongue actually pushes this towards your pharynx area back here, okay? And that ball is called a bolus, B-O-L-U-S, okay? And this bolus is basically physically and chemically digested food, okay? It looks completely different from the original food that you put into your mouth. So if this is a cracker, okay, it now resembles a mushy ball of stuff that looks nothing like the hard cracker that you put into your mouth. It's a mixture of saliva, okay, a little bit of mucus, and basically ground up cracker. And your tongue is going to push this towards the back of your throat, okay, and it's going to push it down here. Now, I want us to actually look at what's going on down here. Okay, this next part of ingestion is very important because at the bottom of the throat is where your esophagus and your trachea merge. Okay, it's the beginning of both of these pipes or tubes, okay, that do very, very different things. Because your nasal cavity and your mouth are openings for air, and your mouth is an opening for food and water. Okay? That's efficient to not have separate openings like that. But the problem here is you've got to make sure that food does not go down the trachea and that air does not go down the esophagus. Because having air in your stomach does nothing for your stomach. Okay? It gives you gas. Okay? It gives you the hiccups. It makes you burp. All right? It can give you a feeling of discomfort. Having food go down your trachea can actually lead to choking. All right? So, what actually figures out or what actually prevents this from happening is a specific flap at the base of your throat. And this flap right here is called your epiglottis. And the epiglottis's role is to cover the actual trachea when you are swallowing food. So if you look at this crude little drawing here, you'll notice that the epiglottis is off to the trachea side here. And it's this thin, it's not skin, it's thicker, it's got cartilage in it, okay, which means it's not as strong as bone, but it's stronger than actual soft tissue. And what ends up happening as this actual bolus makes its way down, okay, as it actually makes its way down here and it gets closer and closer, it's going to cause, and I'm going to actually erase this right here and draw it back over again, it's going to cause the actual flap here to full on cover the trachea. This is your trachea. This is your esophagus. So it causes the actual bolus to be forced down the esophagus. It causes the liquid that you're consuming or the solid food that you're consuming to be forced down the esophagus. Okay? It blocks it from entering the trachea so you don't choke. Now, this doesn't always work. You can sometimes be trying to speak and eat at the same time, or somebody can startle you while you're chewing something, or you cannot chew something very well, and it can actually go down your trachea a bit, okay, and it can cause you to cough excessively, all right? This is not 100% fail-safe, but it actually works quite well. I like to think of the epiglottis as one of these sliding doors that just goes back and forth all the time. Okay? When you are breathing, the esophagus does not cover the actual, the epiglottis does not cover the esophagus. Leaves it open. And we'll learn when we talk about the respiratory system, we'll learn why the air is forced down the trachea. Okay?